Maxwell's electromagnetic equations are equivalent to the Kirchhoff's law, Kirchhoff's current law as well as Kirchhoff's voltage law. How? Okay, so now we know about that fundamental base, okay, or fundamental connection between Maxwell's electromagnetic law with the Kirchhoff's laws. Okay, now from the Maxwell's equation, what is the fourth equation? Okay, what is the Maxwell fourth equation? Maxwell's fourth equation is defined Carl H equals to J plus del D del T. Okay, so where H is the magnetic strength, basically B is the magnetic field and D is the displacement current. Okay, so this is also a also the form of Ampere's law. After correction of Maxwell's introduced this displacement current concept. Okay, now take the divergence both sides. So divergence of Carl H equals to divergence of J plus del D del T. Now divergence of curl of any vector field is 0 basically. So here we get divergence J plus del T of divergence D. Okay, now again from Gauss law we'll know that the divergence of D is nothing but rho. So divergence J plus del rho del T equals to 0. Okay, so therefore we get divergence J is nothing but minus del rho by del T. Okay, so we get this expression from the fourth Maxwell relation or equation. Okay, in EMT. Okay, so this is the expression we derive, that is the divergence J equals to minus del rho by del T. Okay, now if we take a volume V, we take a volume V, okay, which enclosed by a surface area, S. Okay, so here we consider a volume V which is enclosed by a surface area S. Okay, so after that if we integrate both sides, okay, if we volume integrate both sides of this expression, then we get divergence J dV equals to minus del rho by del T integration of dV. Okay, now divergence of J, so this is the volume integral. So if we want to convert this volume integral into the surface integral, so we have to apply here the Gauss divergence theorem. Okay, so it becomes S J dot ds. Okay, this is the closed surface integral. J dot ds is equals to minus del T of, this is basically rho into dV full volume. So this gives basically the charge. Okay, so surface integral of J dot ds equivalent to minus del Q by del T. So del Q by del T is nothing but the rate of change of charge, that is basically evolution of charge. Okay, now we know that is J equals to current density, so it can be expressed in terms of current divided by area, here also area. So basically this closed surface integral of J dot ds gives us the gives us the summation of current or sum of current. Okay, that is it gives effectively the sum of currents in all the conductors passing through this surface, okay, passing through this surface area S, passing through this surface area S, okay. So it gives all the current passing through this all the current in all conductors passing through this surface area S, okay. Now if we take it as discrete way, so it is basically total current. So in discrete way it can be written as summation over S is, okay. So this is the current in all conductor passing through this volume or passing through this surface, that is this in discrete way summation is is, that must be equals to minus dq by dt. Now here q is the total charge, okay. So q is the total charge and dq by dt is the evolution of charge with respect to time, okay. Now this value is very negligible, okay. So we can neglect this term, we can take it as a 0. So therefore we get summation over S surface is equals to 0, that is the sum of all current, okay, in for all conductor passing through this surface area is 0, okay. So it gives the corresponding the conservation of charge. So since dq dt equals to 0, so conservation of charge, okay. Now again we know that KCL, that is the Kirchhoff's current law. Kirchhoff current law states that, so if we have a node here A, then the total incoming current at this node is equivalent to the total is equal to the total outgoing current, okay. So if incoming currents are I1, I2, I3 and outcoming currents are I4, I5, I6, then we get I1 plus I2 plus I3 is equal to I4 plus I5 plus I6, okay. Therefore we get I1 plus I2 plus I3 minus I4 minus I5 plus I6 equals to 0. Therefore we get summation of I equals to 0, that is the total current is 0, summation of total current or sum of total current is 0 at a node. So this is the Kirchhoff's law. So we ultimately get the Maxwell's equation, fourth Maxwell's equation is analogous to the Kirchhoff's current law, which corresponds to the conservation of charge, okay. So similarly we can show that the uh, Maxwell's third equation, okay, that is the relation between E field and B field, that is curl of E is nothing but minus del B by del T, okay. So if we take the surface integral both side, then it gives curl E dot ds equals to minus del t of integration b dot ds. Now curl dot ds, so here's surface integral. So if we want to take it as a line integral, so we have to use Stokes theorem. So here it will be a closed line integral of E dot dl, okay. And here B dot dl is nothing but total flux phi, okay, total flux phi. So B dot dl, so it will be minus del phi by del t, okay. Now we consider here a surface S which is enclosed by a curve C, okay. A surface S which is enclosed by a curve C, okay, that is closed line integral of E dot dl. Now E is basically what, 1 by, if we take the form 1 by 4 pi epsilon naught some charge divided by r, okay, r square, and V is basically 1 by 4 pi epsilon naught multiple of charge divided by r. So basically E is nothing but V by r. So here E dot r will be V. So E dot dl is nothing but the voltage, nothing but the voltage. So it is basically voltage, and this is minus d phi by dt. So if we discretize this form, then we get summation over surface Vs equals to minus del phi by del t. Now the time evolution of this time evolution of this magnetic flux is negligible, so we can neglect it, we can take it as a 0. That is del phi by del t is nothing but 0. So if we put del phi by del t is 0, then we get summation s vs is 0. Okay, so the total voltage enclosed by a loop is 0, which corresponds to the Kirchhoff's voltage law. So KVL, which is the indicate the conservation of energy. Okay, which indicate that is the d phi by dt is 0 here, so that's why it indicates the conservation of, or it follows the conservation of energy. Okay, conservation of energy.